Good morning everyone. Welcome to the first lecture of class 12 organic chemistry, haloalkanes and haloarenes. So before starting haloalkanes and haloarenes, we have to know some of the basic terms which we will be using in the entire organic chemistry. Okay, so let us see some of the basic terms which we are using, which we have also learned in class 11 about this. So we will see one by one some of the basic terms which we are going to use in class 12 organic chemistry in haloalkanes and haloarenes, and after that entire whatever the organic chapters are there. So as we all know that we will start from organic chemistry. So when we are talking about organic chemistry is been divided into various branches. You can say one by one we will see that. First of all, organic compound is been divided into two. One is open chain and closed chain. Okay, and after that this open chain is been divided into two, that is saturated and unsaturated. Okay, now next closed chain. This closed chain has been divided into two, that is homocyclic compound and heterocyclic compound. Now again, heterocyclic compound has been divided into two, that is alicyclic compound and aromatic compound. Now, and this heterocyclic compound has been divided into alicyclic and aromatic. Now again, when we are talking about aromatic compounds are also two types. One is benzonoid aromatic compound and another one is non-benzonoid aromatic compound. I hope this thing you know. So now we will see next, which is formal charge, this one. So what is formal charge? When we are talking about the formal charge, so let us see the formula for formal charge. Okay, so formal charge is what? Its formula is number of valence electrons for element, this one, minus number of bond to that atom minus number of unshared electrons. Okay, so we will take one example. Suppose we have some example like this. Example number 1. Suppose we are given a compound like this, CH, hydrogen here also hydrogen, and here one is hydrogen, and here it is hydrogen. So in this example, if we are asked to find out the formal charge for this carbon, okay, so as we all know that carbon, its valence, number of valence electron, carbon, we all know that carbon, what is the atomic number of carbon? So carbon atomic number is 6. So when you will see its electronic configuration, it will be 1s2, 2s2 and 2p2. Okay, so you can see here there is 4 valence electron in the outermost cell. So what we have written, number of valence electron for element, so it will be how much? 4 here. Okay, minus number of bond to that element. How many bond? You count here. One bond is with this hydrogen, one bond is with this hydrogen, and one bond is with this hydrogen. Means how many bond? 3 bond. Okay, 3 minus, what is the formula here? Number of unshared electron. Any unshared electron is there? No. Then we will put here 0. So how much it is coming? 4 minus 3 minus 0, it is plus 1. So this carbon is carrying a formal charge of plus 1. Like this, we can take one more example here. So suppose we are taking the example of this hydrogen here, one oxygen here, and one hydrogen here, and one hydrogen here, and this is the lone pair. So now if you are asked to find out the formal charge of this oxygen, so as we all know that oxygen atomic number is what? 8. So it will be 1s2, 2s2, 2p4, right? So you can see here oxygen 4, 5, 6 means in the outermost shell it has 6 electron, means number of valence electron is how much? 6, minus number of bond to that atom. How many bond is there? 1, 2, 3. 3 bond you can see. One bond is with this hydrogen, one bond is with this hydrogen, and one bond is with this hydrogen. So here it is 3, minus how many unshared electron? Number of unshared electrons. So how many unshared electron is there? 1 and 2. 2 unshared electron. So the formal charge of this is 6 minus 3 is 3. 3 minus 2 is 1. It is plus 1. Okay. So this was about the formal charge. How we have to find out the formal charge? We can take one more example here. Suppose we have a example like this. Hydrogen here. Here is one hydrogen, and here is one hydrogen, and here it is nitrogen, hydrogen, hydrogen, and hydrogen. Suppose we are asked here to find out the formal charge of this nitrogen. So as we know that formal charge value, number of valence electron in nitrogen is how much? 5. How many bond it is forming? One bond with this, one bond with this, one bond with this, and one bond with this, means 4. Minus how many unshared electron? No, means 0. So it will be plus 1. So in this way we have to find out the formal charge. Now next is what? Hybridization. So what is hybridization? We all know, you have learned in class 11. Hybridization is what? It is an intermixing of atomic orbital. Okay. So one basic formula we should know. The formula for hybridization is what? One basic formula you can take like this: sigma bond plus free lone pair. With this formula we can easily find out the hybridization of any compound. Suppose first of all I would like to tell you what is hybridization. Suppose we have to find out CH4. So how it is bonded, you can see carbon is what? If you will see 1s, 2s, and 2p. Okay. So first of all, in the ground state you can see 2 electron here, 2 here, and 1 here, and 1 here, carbon. Okay. When this carbon will be, this one is ground state. Okay. When it will go in excited state, it will be like this: 1s2, 2s2, 2p. This is 1s, this is 2s, and this is 2p. So here will be 2 electron as it is. Here will be 1. Here it will be 1, 1, and 1. Now this has become here 4 orbital, 4 empty orbital. Now since we know hydrogen is carrying only one electron. So one hydrogen will come and attach here, one hydrogen will come and attach here, one hydrogen will come and attach here, and one hydrogen will come and attach here. So that in this way it will form CH4. Now suppose we are giving one compound, random compound, just like this: CH2 double bond CH, CH2, there's C double bond O, again then CH2, then N lone pair NH2, CH2, CH, CH2, C double bond O, CH2, and NH2. Now we are asked to find out the hybridization of this, and this carbon, and this carbon, and this nitrogen. So how we will find out? Then we have to use this formula, this simple formula. From this formula you can easily find out the hybridization in any compound. Okay. So now you see this carbon, how many bond it is making? Sigma bond. We have to find out the sigma bond because no free electron is there. So how many sigma bond? One with this hydrogen, 2 hydrogen is there, means 2 bond. Okay. And one with this, when one with this carbon, means 3. Means how many sigma bond? 1, 2, 3. 3 sigma bond means what? sp2. Are you understanding or not? After that again this carbon, how many sigma bond? 1 with this, 1 with this, and 1 with this. 3 sigma bond means what? Again sp2. After that this, again this one bond with this, 1 with this, and 2 with this. Or if you see here, 2 with this, 1 with this, and 1 with this, means how many bond? 4 sigma bond, means what? sp3. Now again when we are talking about this carbon, This carbon, one bond with this, one sigma bond with this, and one sigma bond with this. How many total? 3 means what? sp2. After that again you can see here this one bond with this, one bond with this, and two bond with this. How many sigma bond? 4 bond. 4 sigma bond means it will be sp3. Now again, when we talk about this nitrogen has two bond with this, one bond with this. How many? 3. And one lone pair is there. You see in the formula free lone pair is there. So one free lone pair, and how many bond? 1, 2, and 3. 3 bond means it will be sp3. So in this way you can find out the hybridization of any compound, and I hope you know the type of hybridization. Hybridization is sp hybridization, sp2 hybridization, sp3 hybridization, and sp3d hybridization. In this way there are 5 to 6 type of hybridization. I hope you know about this. So this was the basic formula from which you can find out the hybridization. Okay, so now next, drawing structure. I hope all of you know the how to draw the structure, but let me tell you. Suppose we are asked to draw the 3D structure of CH4. Okay, so how you will draw the 3D structure of CH4? You can draw like this. See here. So this one is carbon. One carbon will be this, one will be this, and one will be this, like this, and one will be this. So this dash, this you can see here, this one, the shaded one, this represent what? It means that the hydrogen, this hydrogen is in front, okay, and this one, the shaded one, the dotted line, this one is in the back side, or we can say that behind. So in this way we can draw the 3D structure. Okay, now after this, you see how many type of structure is there. Electron dot formula is there, dash formula is also there, condense formula is there, bond line formula is there, and ball and socket like formula. So one by one we will see. If we are asked to draw the bond line formula, so bond line formula we have to do like this. You have seen bond line formula like this. Okay, if we are asked to find out the condense formula will be CH3 CH2 CH2 OH, like this. Okay, if we are asked to find out the dash formula, dash like formula, so how we will write? Carbon here, one hydrogen here, one hydrogen, again this carbon, one hydrogen here, one hydrogen here, and again this one hydrogen is here, one hydrogen is here, one oxygen here, and one hydrogen is there. So in this way there are structure formula and various type of structural formula is there. Okay, now next, what is this? Bond length and bond strength and bond length. Okay, so for this bond strength and bond length, I will tell you simple thing from where we can identify the bond strength or bond length. Suppose we have here carbon single bond. Okay, this is carbon single bond, and this one is carbon double bond, and this one is carbon triple bond. Okay, so when we are asked to find out which one will be where the bond length will increase and where the bond strength will increase, so we can easily tell that bond strength, and here suppose we are writing bond length. So always remember that single bond, carbon single bond will be, the bond length will be more. Okay, this one, his bond length will be more than this, and when we are talking about the strength will go like this. Okay, this will be more, the carbon triple bond will be more stronger, and then carbon carbon double bond, and then carbon carbon single bond. Means what? Length, if we are talking about length, bond length, then single bond length will be more. If we are talking about bond strength, then triple bond strength will be more. Okay, so this was about the bond length and bond strength. Now electronegativity, next is what you can see here, electronegativity. Okay, so when we are talking about electronegativity is what? Electronegativity is a measure of an atom's attraction for electron in a bond. Okay, so when we are talking about electronegativity, we can easily find out like this. We have heard, I know you have heard about non-polar bond, non-polar bond and polar bond, suppose. So from here we can identify the electronegativity. Your electronegativity concept will also be clear, and about the polar and non-polar bond. Suppose we have here carbon and carbon. Okay, carbon and carbon. Suppose this carbon is hydrogen, hydrogen, here also hydrogen, here also hydrogen, and here also hydrogen. So when we are talking about the electronegativity, this one is also carbon and this one also is carbon, then the electron density will neither shift to this side nor shift to this side, because this carbon also has also had a electronegativity of 2.5, and this one also has electronegativity of 2.5. So this type of bond where the electronegativity of the bonded atoms are same or exactly same, then the electron will not neither shift to this side, the electron density will neither shift to this side, then this type of bond is called non-polar bond. Okay, now when we are talking about the polar bond, which type of bond will be polar bond? So in this case you can take a simple example. Suppose we have carbon carbon double bond oxygen, and here is hydrogen, suppose here in hydrogen. So you know that carbon has an electronegativity of 2.5. okay, this one has an electronegativity of 2.5, and this oxygen has an electronegativity of 3.4. then what you will see, this the electron density will shift towards the oxygen. So what will happen, this oxygen will carry a partial negative charge, and this carbon will have partial positive charge because of electronegativity difference. Since electronegativity of oxygen is more than carbon, so the electron density will shift towards the oxygen. So this will generate a partial negative charge, and this carbon will generate a partial positive. Okay, so this was about your polar polar bond. The polar, you can easily identify if if in both the in this case you can see in both the carbon has same electronegativity, means they are non-polar, they will, the bond which will form here, it will be non-polar bond. But here you can see that the oxygen is more electronegative than carbon, so the electron density will shift towards oxygen, and the bond which will generate here, this type of bond is called polar bond. Okay, so this was about your polar and non-polar bond. Now we will see next. Now we will see breaking of bond. So bond breaking, when we are talking about the breaking of bond, or we can say that bond breaking, it will be of two types. One will be heterolysis, another one will be homolysis. Okay, heterolysis and homolysis. So we will see which one is heterolysis and which one is homolysis. Suppose we have A and bounded to B. Okay, so when the bond is breaking here, one electron is shifting towards B and one electron is suppose shifting towards A. Means what? Both the element, or both the element after breaking has distributed equal number of electrons. One electron has shift here and one electron has shift here. Means what? There is an equal distribution. We can say like this one A and this one B. So this type of bond where the bond is breaking, when the bond is breaking and equal number of electron is shifting on both the side, then this type of bond breaking is called homolysis. Okay, and the compound which is formed, or we can say that the substance which is formed by homolysis is called free radicals. I hope you have heard this, free radicals. Now heterolysis, when suppose this A and there is B, and when the bond is breaking, this B is taking both the electrons. Okay, so A will generate a partial positive charge and B will generate a partial negative charge. Then this type of bond breaking is called heterolysis, and in this case one is formed, that is cation, and another one is formed which is called anion. Okay, so this was about your breaking of bond, and after that bond breaking is completed. Now this one is over, this one is over. Now nucleophiles and electrophile, we will see this one, nucleophile and electrophile. Okay, so when we are talking about nucleophile and electrophile, nucleophile is what? I hope all of you know about nucleophiles. So nucleophile is what? Let me write. Nucleophile is what? Nucleus loving. Nucleus loving. Okay, so nucleophiles are what? Nucleophiles are electron rich species having an electron pair available for donation. Okay, are you getting this? Nucleophile is what? Nucleus loving. These are those substances which are electron rich species having an electron pair available for donation. You can take so many examples, just like CH3 negative, Cl negative, I negative, RO negative, NH2 negative, OH negative, or CH3 COO negative. So these are some of the nucleophiles which are nucleus loving. Okay, one more you can take which are in neutral, suppose H2O, after that ROH, and suppose NH3 or RNGX. This type of, these are the substances which are nucleophiles. Now next, electrophile. Electrophiles are what? Electron loving. Electron loving. Okay, so electron loving, these are the substances which are electron deficient species having an empty orbital to receive electron pair from nucleophile. Are you understanding or not? These are the substances which are in which there is a deficient of electron and it need an electron, and who will donate them an electron? Nucleophile will donate. Okay, so there are so many examples. Some of the examples we will see here: CS3 plus and X plus, NO2 plus, or sometimes ALX3 or BeCl2 or SO2 or SO3. So these are the substances which are electrophiles, which need electron. They have empty orbitals and it need electron. Okay, now next. Next is what? Movement of electrons and the use of arrow, and after that resonance. Okay, so you will see. Always remember that movement of electron will be always from higher density to low electron density. Okay, just like this. Suppose we have OH here. Okay, and here is CH3 dash CH dash CH3. Suppose this is carrying a positive charge. So electron will always move from higher electron density to lower electron density. Okay, It is not like this, it will not be like this. Suppose here to here, this is wrong, this will not. Always remember that electron will always jump from higher electron density to lower electron density. And one more, if there is a single electron, movement of single electron, then we will denote this with this half arrow, which is called fish hook arrow, we say, na, fish hook arrow. So we will denote like this. Okay, so this was all about your electron density. Now next, last topic is what about resonance. Okay, so resonance is what? I hope you have learned in class 11 about resonance in detail, but I will give you some basic idea, not in detail. So resonance is what? Delocalized electron, or we can say that pair bond. So there are some rules which you have to remember about resonance. Is that resonance structure exists only on a paper and no real existence, and it has no real existence. All of you should remember this, that resonance, when we are talking about resonance is only on a paper. They doesn't have any real existence. Okay, resonance stabilize the molecules. Whatever the molecule is there, due to resonance stability, they used to gain stability. Okay, and one main very important things you have to remember, that in resonance only pi electrons are allowed to move. Okay, not sigma electrons, only pi electrons are allowed to move in resonance. Okay, so one resonating structure we will see. All of you know about this, no? Benzene ring. You donate like this, no? So it will move it once, it will delocalize, and it will become, since it was lone pair was here, so at that time it will come here. This was here, it will come here, and this will come here, like this. As a whole, how we can denote this? We will denote like this, circle, right? So this was a resonating structure. So one or two example we will see about the resonance. So in resonance, one thing you always remember, that conjugation. Okay, conjugation, this you always remember. Conjugation is what? It is nothing but a continuous availability of empty p orbital. Okay, you have to always remember that if you have to see, we have to find out that if suppose you have given the compound, and you are asked to tell that in this compound resonance is possible or not. So how you will tell? You have to simple follow a single rule, which will be charge, single bond, charge. Okay, this is the basic terms which you have to remember to find out, to identify where, in which molecules resonance is happening, and in which structure resonance is not possible. Okay, and one more thing, always remember that to have a resonance, there should be an empty p orbital. Okay, if there is not having any empty p orbital, then resonance is not possible. Okay, so now let us take one example, okay, of a resonance. You can take any example. Suppose we have this. We have nitrogen double bond oxygen here, and here it is one methyl group, and here it is oxygen, which is carrying 6 unpaired electrons. Okay, here this one is carrying plus charge, and this one is like this. So now if we are asked to find out the resonance of this, so first, for what is the basic rule what we have to remember? Charge, single bond, charge. So you see here, charge, single bond, charge. Here also charge, and charge, single bond, charge. Like this we have to remember. Okay, so what will be the resonating structure. Next resonating structure, this negative will move to this side and this one will move to this side. So next structure will be like this: oxygen, nitrogen. This will become double bond here, one methyl group is here, this one is plus and this one is O, 1 2 3 4 5 6, and this will become negative here. Now next what we can do, now if we are as a whole, what we can write here: nitrogen double bond O positive, here we can write CH3, and here oxygen. So this was the resonating structure which we have to remember. Okay, now one more example we will see. Suppose we are given a molecule like this. I hope you can see this. Suppose we are given here this one, and here it is like this, O, and this one. So we have to draw the resonating structure of this compound. So it will form 7 resonating structure. How? You will see that. First of all, this single bond, this pi bond will jump here in first case. So it will become like this. Okay, it will become like this. Here it is positive charge and here it is oxygen. Now next, this double bond will jump here. Okay, so in the next case it will form like this. Double bond, here oxygen, negative charge, and this will become plus. Now again, this bond will jump here. Okay, so next structure will be like this. Like this, it will become here plus, this one is here, this one is here, and this will again double bond here, oxygen, negative. Okay, after that again this double bond will jump here, and in the next case what we can write like this: here double bond, plus will shift here, and this one will be here. Okay, now next, again what will happen, this double bond will jump here. Now in the next case what we can write: here one, here one, here one, and here oxygen. Sorry, this one is this one is oxygen. Here you will get plus charge. Now again this will jump here, and in the last what we can draw, again it will be like this. So this was the resonating structure. How many resonating structure you can say? 1 2 3 4 5 6. So this was all about the basic ideas about the organic chemistry. Now from the next class we will start haloalkenes and haloarenes. Okay, to that, thank you.